Hey everybody, we're going over section 4, multiplying and dividing rational expressions today. And our goal for today, or our objective, is students will be able to multiply and divide rational expressions in order to compare the efficiencies of designs. And we'll do that later in our practice assignment. So for today, let's go ahead and start with some key terms. And the first key term is simplified form. So keep in mind, simplified form means that the numerator and denominator have no common factors. Meaning they can't be divided by any same thing on top and bottom. So in order to simplify, you would divide out a common factor or all common factors from both the top and the bottom, or numerator and denominator. So here's what that means. So for example, let's say I've got this: simplify x squared minus 2x minus 15 over x squared minus 9. So we need to simplify that. So remember, in order to have this be simplified, we need to make sure there are no common factors. In order to make sure there's no common factors, the first thing I'm going to do is I'm going to factor both the numerator and the denominator. So I'm going to need to factor them each separately. So let's take this one first. So if I've got x squared minus 2x minus 15, that's a trinomial, so I can use my x factoring method. What multiplies to negative 15 that adds to negative 2? Well, I know 5 and 3 will multiply to 15. And if 5 is a negative, that will add to a negative 2. So I'm going to factor this down to x minus 5 times x plus 3. Okay? And then for this one, I'm going to factor this down here. I can see that there are a difference of 2 squares, which tells me when I factor this, I can take the square root of x squared as x, and the square root of 9 is 3, and 1 is a plus and 1 is a minus. Okay, so I've factored them. Now number 2 is I'm going to look. Okay, we're going to look for a common factor. So let's look at the top and the bottom now that we've factored them. Do we have a common factor? Well, let's look. I see x plus 3 here, ooh, and an x plus 3 here. If we see a common factor, that's when we know you're going to cancel them, meaning divide them out from each other. Because if I have an x plus 3 being multiplied on both top and bottom, I can divide them out or they cancel. Okay, this is the fruit ninja step, slash, slash. So they cancel each other out, and what we have left is x minus 5 over x minus 3, and that's our simplified form, okay? And the only thing that you would do after this is just make sure that there's no other factors, which we know that they are not. All right, moving on. Let's go to multiplying rational expressions. So when we multiply rational expressions, remember that the property looks like this. When I've got some fraction, a over b, times another fraction, c over d, we take the top 2 numerators and multiply them by each other. And then we take the bottom denominators and multiply them by each other to make one big rational expression or fraction, okay? So let's look at this example number 2. I'm going to go ahead and multiply across the top. So again, we multiply across the top. We know 5 times 6 is 30. X squared times x is x to the third. And y cubed multiplied all that is all of this multiplied together. And then divided by, and now we're going to multiply across the bottom. I know 2 times 10 is 20. X times y squared times y is y to the third. And now, in order to simplify this, we will find those common factors. Well, I know 30 and 20, I can pull a 10. So both of those can be divided by 10. So if I take 30 and divide by 10, it leaves me a 3. And if I divide by 20 by a 10, it leaves me a 2. Okay? Same thing here. If I know I've got 3 x's on the top and 1 x on the bottom, one of the x's from the bottom will cancel out with one of the x's from the top and leave me 2. And then we've got 3 y's on the top and 3 y's on the bottom, which will cancel both out from each other. Now, one of the things I like to do is circle what we have left so that I'm not confused. So I've got a 3x squared and a 2 on the bottom. So now I'm gonna rewrite this so I can read it. So we go 3x squared on the top and a 2 on the bottom. And that's our most simplified form of that multiplication. All right, let's do the next one. And this time we're multiplying, but this looks a little different. There's more to it this time. So when we multiply this one, we're gonna go ahead and remember that at the end, once we've multiplied it all the way through, we might have to cancel out some things. So here's the hint. When you see that these are trinomials or binomials being multiplied by each other, and instead of multiplying them all out, we're gonna put these in factored form first. Okay, so let's go ahead and factor this right here. I'm gonna put it right here. So I know 3x and 3x squared both have a 3x in common. So if I pull out that 3x, I'm gonna get 1 minus x, okay? And that's because if I multiply 3x times 1, I get 3x again, and 3x times negative x gives me a negative 3x squared. So that's factored. Let's factor the denominator here. We're gonna put this on the bottom right here. Let's see, it's a trinomial, so we have to figure out what multiplies to negative 5 that will add to a positive 4. Well, I know 5 and 1 can multiply to 5, and if I make it a negative 1, it will make a positive 4. So we can say, well, I know x times x gives me x squared, and if I put the plus 5 factor here and the minus 1 there, we're good to go. Okay, we've done with that side, and now I'm just going to bring this multiplication down, and now I'm going to factor this one on top. Now remember, this one on top, we have to think, okay, what multiplies to negative 20 and adds to 1? Well, I know 4 and 5 can work where the 4 is negative. So this becomes x minus 4 times x plus 5. And then there's nothing that can factor here, so that's just going to be a 3x. Now, when I multiply everything together, it's basically saying like 3x times 1 minus x times x minus 4 times plus 5. So I can rewrite this as one big happy fraction. Okay, so I'm going to rewrite this right here. 3x times 1 minus x times x minus 4 times x plus 5. All over x plus 5 times x minus 1 times 3x on the bottom. So again, we multiplied across the top and we multiplied across the bottom. And now we're going to cancel any common factors that we might have. So let's try this. We know 3x and 3x are gone. They're canceled. Perfect. I see a x plus 5 and an x plus 5. Those are canceled as well. Now, I do see something here that is really interesting. This is a 1 minus x, and this is a x plus 1. So they're super close, but not exactly there. So I'm just going to rewrite this. This is what's left. What happens with this is if I multiply, let's just say the bottom, if I were to multiply this by a negative 1, Okay, if I were to pull out a negative, this would make this into a negative x positive 1. So I'm not changing the value. If I pulled out a negative 1, it would give me negative x plus 1, which is what I see here, a negative x and a plus 1. So now this will cancel here. And I'm left with x minus 4 all over negative 1, which if I were to simplify that, that's x over negative 1 is negative x, and negative 4 over negative 1 is positive 4. Okay, so remember now, if I'm going to multiply something that looks like this, just keep in mind that even though x squared plus 3x plus 9 here is not a fraction or a rational expression, we can write it as over 1. Okay, so when we do that, you can still say, well, this would be x plus 2 times x squared plus 3x plus 9 all over x cubed minus 27 times 1, which is just itself. And then from here, you would factor, cancel like factors, and then make sure it's simplified. Okay, we're not going to do that one together, but I just wanted to remind you that when you don't have a denominator, the denominator is 1. All right, let's go into dividing rational expressions now. So when we're dividing rational expressions, we're going to multiply by the, hopefully you remember, reciprocal. Remember, a reciprocal is when we flip the numerator and denominator and they become the other. So for example, we're going to multiply by the reciprocal of the second rational expression. So we keep the first fraction, change the division to multiplication, and do the reciprocal of the second one. So that's what we did here. We kept the first fraction, changed the division to multiplication, and we made the reciprocal of c over d, which is d over c. Once we have that, now we just multiply, which we know how to do already. So we're going to say a times d is ad, and b times c is bc right here. Okay, so let's practice that. So here we've got a division problem where we're going to divide these two things. Now remember, we're going to keep the first fraction, turn the division into multiplication, and then take the reciprocal of the second. So now the bottom, which is x squared minus 11 plus 30, is now the numerator. And the top from before is now the denominator here. So now we're ready just to multiply it, which we already know how to do. Remember, when we multiplied, we still would put this in factored form. So we changed the division problem into a multiplication problem, and now we're going to factor. So we know 7x can't really factor, it's just 7x. 2x minus 10, I could factor out a 2, and we're going to get x minus 5. Okay? Let's do the next one. So here's our multiplication. Now we're going to factor x squared minus 11x plus 30. So we know if we were to do this, we could do our x factor process where we know something has to multiply to 30 but add to a negative 11. We could use negative 5 and negative 6 for this, which tells me that when I factor this right here, we're going to have x times x is x squared, and our factors are negative 6 and negative 5 that will multiply to positive 30 and add to negative 11. And then the last thing we need to factor is this x squared minus 6x. We see they both have a common factor of x. So when I pull that out, I get x minus 6. Okay, so everything is factored now. We're going to rewrite it. So 7x times x minus 6 times x minus 5 all over 2 times x minus 5 times x minus 6. So again, we multiplied across the top, multiplied across the bottom. And now we're going to cancel any like terms. So I know x minus 6 and x minus 6 are both on top and bottom. We can cancel those. X minus 5 and x minus 5 cancel. And the 7 times x is its own factor. We can cancel that out with right here. So we're left with, I'm going to go and circle them, 7 over 2 And we're done. Okay. All right, I will see you back in class.